Since there are now 3 ground rods, connect them properly to meet requirements. Firstly, install the 3rd ground rod. Drive the 3rd ground rod between the existing 2, approximately 3 feet from each. Secondly, bond the ground rods. Connect all 3 ground rods together using number 6 AWG solid bare copper wire. Use mechanical connectors such as C-clamps or ground rod connectors. Thirdly, ground all 3 rods to the service. Run 3 separate number 6 AWG copper wires from each ground rod back to the service entrance panel. Connect the wires to the grounding electrode conductor GEC at the service panel. Fourthly, check resistance. Measure the resistance between each ground rod and the service panel. The resistance should be as low as possible, ideally below 25 ohms. Consider these additional points. If the resistance is still high, more ground rods may need to be installed. The ground rod should be driven at least 8 feet into the ground, preferably more. The ground rods should be at least 6 feet apart to ensure proper grounding. Make sure all connections are tight and secure. Benefits of 3 ground rods include improved grounding performance and lower resistance, redundancy in case one ground rod fails, and compliance with most electrical codes. Always consult with a qualified electrician or follow the manufacturer's instructions when working with electrical installations. Grounding is a critical aspect of electrical safety, designed to protect people and equipment from electrical faults. The purpose of a grounding system is to provide a low-resistance path for fault current to return to the source, which in turn causes the overcurrent protection device, such as a circuit breaker or fuse, to trip and to energize the circuit. This process prevents electrical shock hazards and minimizes the risk of fire or equipment damage. Ground rods are an essential component of a grounding system, especially in residential and commercial buildings. They provide a direct connection to the earth, allowing fault currents to dissipate safely. The National Electrical Code, NEC, sets specific requirements for grounding electrode systems, including the number, type, and installation of ground rods. These requirements are in place to ensure that the grounding system is effective and reliable. The minimum requirements for ground rods typically involve installing at least 2 ground rods that are spaced at least 6 feet apart. This spacing is necessary to ensure that each ground rod is in a different area of earth, maximizing their effectiveness in dissipating fault currents. If a single ground rod is used and it does not achieve a resistance to ground of 25 ohms or less, a second ground rod is required. The 25 ohms threshold is a benchmark for ensuring adequate grounding performance. Installing multiple ground rods in a triangular or linear configuration can further improve the grounding system's performance. When installing ground rods, it is crucial to follow the NEC guidelines and local electrical codes. The ground rods must be at least 8 feet in length and driven into the ground so that at least 8 feet of the rod is in contact with the soil. The top of the ground rod should be flush with or below ground level to protect it from physical damage and ensure safety. The connection between the ground rod and the grounding electrode conductor, GEC, must be made with a listed connector suitable for direct burial. This connection should be corrosion resistant and mechanically strong to ensure a reliable electrical connection over time. The grounding electrode conductor, GEC, is the conductor that connects the ground rod to the service equipment, such as the main service panel. The size of the GEC is determined by the size of the service entrance conductors, as specified in the NEC Table 250.66. The GEC must be properly sized to carry the maximum fault current that could flow through the grounding system. Proper installation of ground rods and the grounding electrode conductor is essential for ensuring the safety and reliability of the electrical system. It is recommended to consult with a qualified electrician to ensure that the grounding system meets all applicable codes and standards. Regular inspection and maintenance of the grounding system are also important to ensure its continued effectiveness. This includes checking the connections for corrosion, verifying the resistance to ground, and making any necessary repairs or replacements. Additional considerations for ground rod installation include the type of soil and the presence of underground utilities. The type of soil can affect the resistance to ground, with sandy or rocky soils typically having higher resistance than clay soils. If the soil is not conducive to grounding, it may be necessary to use longer ground rods or install additional ground rods to achieve the required resistance. Before driving ground rods, it is essential to check for underground utilities to avoid damaging them. Contacting the local utility companies to locate any buried cables or pipes is a crucial safety measure. In some cases, it may be necessary to use alternative grounding methods such as ground plates or concrete-encased electrodes if ground rods cannot be installed due to site conditions. Ground plates are metal plates that are buried in the ground to provide a larger surface area for grounding. Concrete-encased electrodes, also known as UFA grounds, are grounding electrodes that are encased in concrete foundations. These methods can be more effective in certain soil conditions or where space is limited. Grounding systems are not only important for safety but also for the proper functioning of sensitive electronic equipment. Electronic devices are susceptible to damage from voltage surges and electrical noise, which can be mitigated by a properly grounded electrical system. A well-designed grounding system provides a stable reference point for voltage, reducing the risk of equipment malfunction or failure. Regular testing of the grounding system is recommended to ensure that it is functioning correctly. A ground resistance tester can be used to measure the resistance between the grounding electrode and the earth. This test should be performed periodically, especially after any modifications or repairs to the electrical system. If the resistance is found to be higher than the acceptable limit, corrective action should be taken to improve the grounding system. This may involve installing additional ground rods, improving the connections, or using soil amendments to reduce the soil's resistivity. Understanding the principles of grounding and following the NEC guidelines are essential for ensuring electrical safety and equipment protection. A properly installed and maintained grounding system is a critical component of any electrical installation. Remember to always consult with a qualified electrician for any electrical work, including the installation and maintenance of grounding systems. Their expertise will ensure that the work is done safely and in compliance with all applicable codes and standards. In summary, a grounding system with multiple ground rods offers several benefits, including improved grounding performance, low resistance, and redundancy. Proper installation and maintenance of the grounding system are essential for ensuring electrical safety and equipment protection. Always consult with a qualified electrician to ensure that the grounding system meets all applicable codes and standards. When dealing with 3 ground rods, there are a few important things to keep in mind. Firstly, the placement of the 3rd ground rod is crucial. It should be installed in a location that maximizes its effectiveness in dissipating fault currents. Ideally, it should be placed equidistant from the other 2 ground rods, forming a triangular configuration. This arrangement helps to distribute the fault current more evenly and reduces the overall resistance to ground. Secondly, the connection of the ground rods is also critical. All 3 ground rods must be connected together using number 6 AWG solid bare copper wire. This wire should be securely fastened to each ground rod using mechanical connectors such as C-clamps or ground rod connectors. The connection should be made in a way that ensures a low resistance path for fault current to flow between the ground rods. Thirdly, the grounding electrode conductor, GEC, must be properly sized and connected to the service panel. The GEC is the wire that connects the ground rods to the main service panel, providing a path for fault current to return to the source. The size of the GEC is determined by the size of the service entrance conductors, as specified in the NEC Table 250.66. The GEC should be connected to the service panel using a listed connector that is suitable for the purpose. Fourthly, the resistance to ground should be measured to ensure that the grounding system is functioning properly. The resistance to ground should be as low as possible, ideally below 25 ohms. If the resistance is higher than 25 ohms, additional ground rods may need to be installed to improve the grounding system's performance. Fifthly, regular inspection and maintenance of the grounding system are essential. A connection should be checked periodically for corrosion or damage, and the ground rods should be inspected to ensure that they are still properly driven into the ground. Any necessary repairs or replacement should be made promptly to maintain the effectiveness of the grounding system. In addition to these considerations, it is also important to be aware of any local codes or regulations that may apply to ground rod installations. Some jurisdictions may have specific requirements for the number, size, or spacing of ground rods. It is always best to check with the local electrical inspector or building department to ensure that the grounding system complies with all applicable codes. Grounding is a critical aspect of electrical safety, and it is essential to take the necessary steps to ensure that the grounding system is properly installed and maintained. By following these guidelines and consulting with a qualified electrician, you can help to protect people and equipment from electrical hazards. When connecting the ground rods to the service panel, use separate conductors. This ensures that each ground rod has its own dedicated path back to the service panel, which can improve the overall performance of the grounding system. Make sure that the connections at the service panel are also secure and corrosion resistant. Use appropriate connectors and apply an antioxidant compound to prevent corrosion. The grounding system is designed to provide a low impedance path for fault current to flow back to the source, which helps to trip the circuit breaker or fuse and to energize the circuit. This is an essential safety feature that protects against electrical shock and fire hazards. If the grounding system is not properly installed or maintained, it may not function as intended, which could put people and equipment at risk. Always consult with a qualified electrician for any electrical work, including the installation and maintenance of grounding systems. They have the knowledge and experience to ensure that the work is done safely and in compliance with all applicable codes and standards. Remember that grounding is not the same as bonding. Grounding provides a path for fault current to return to the source, while bonding connects non-current carrying metal parts together to create a low impedance path for fault current to flow. Both grounding and bonding are important for electrical safety, and they work together to protect against electrical hazards. In some cases, it may be necessary to use supplemental grounding electrodes, such as ground plates or concrete-encased electrodes, in addition to ground rods. These supplemental electrodes can be used to improve the grounding system's performance in areas with high soil resistivity or where ground rods cannot be installed due to site conditions. The decision to use supplemental grounding electrodes should be made in consultation with a qualified electrician. They can assess the site conditions and determine the best approach for achieving adequate grounding. Grounding is a complex topic, and it is important to have a thorough understanding of the principles involved. If you are not familiar with grounding, it is best to leave the work to a qualified electrician. They can ensure that the grounding system is properly installed and maintained, protecting people and equipment from electrical hazards. The NEC provides detailed requirements for grounding and bonding, and it is essential to follow these requirements when installing or maintaining electrical systems. The NEC is updated every 3 years, so it is important to stay current with the latest edition. A qualified electrician will be familiar with the NEC requirements and can ensure that the electrical system complies with all applicable codes and standards. Grounding is not a one-size-fits-all solution, and the specific requirements for a grounding system will vary depending on the application. Factors such as the size of the electrical system, the type of equipment being used, and the soil conditions will all affect the design of the grounding system. A qualified electrician can assess these factors and design a grounding system that is appropriate for the specific application. Grounding is an essential part of electrical safety, and it is important to take it seriously. By following the guidelines and consulting with a qualified electrician, you can help to protect people and equipment from electrical hazards. Also, the inspector requested that the ground rods be spaced 6 feet apart, which is the code minimum for proper soil dissipation around each rod. You can still install one in the middle, but make sure the inspector will be happy with the final outcome.